We connect M, N, and Q together, and that forms a triangle sitting inside our square. We're told the angle at N, that's angle MNQ, is exactly 90 degrees. We're also given two side lengths, MQ equals 13 and NQ equals 12. Our job is to find X, the side length of the square. Let's start with triangle MNQ, since we already know it has a right angle at N. Whenever we have a right triangle, we can use the Pythagorean theorem, which tells us that the square of one leg plus the square of the other leg equals the square of the hypotenuse. Here, the hypotenuse is MQ, so we write MN squared plus NQ squared equals MQ squared. Let's substitute what we know. NQ is 12 and MQ is 13. So we get MN squared plus 12 squared equals 13 squared, which becomes MN squared plus 144 equals 169. Now subtract 144 from both sides, and we're left with MN squared equals 25. Taking the square root of both sides, MN equals 5. Great. So now we know all three sides of that middle triangle. Now here's where it gets interesting. Let's think about point N and the straight line it sits on. Since S and R are both endpoints of the bottom side, and N sits right on that line, the angles around point N along that straight line must add up to 180 degrees. We already know the angle inside our triangle, angle MNQ, takes up 90 degrees of that. So the other two angles, the ones on either side of it, must together make up the remaining 90 degrees. Let's call those two angles alpha and beta, so alpha plus beta equals 90 degrees. Now notice what happens here. Let's look at the small triangle in the corner at S. That's triangle MSN. It has a right angle at S because it's a corner of the square. One of its other angles is alpha from our straight line argument. So its third angle has to be beta, since all three angles in a triangle add up to 180 degrees. Now let's check the other corner triangle, the one at R, that's triangle NRQ. It also has a right angle, this time at R. One of its acute angles turns out to be beta, using that same straight line reasoning, which means its remaining angle must be alpha. Pay attention to this part, because it's the key move in the whole problem. Both of these corner triangles, MSN and NRQ, have exactly the same three angles, 90 degrees, alpha, and beta. When two triangles have all matching angles, we call them similar triangles, and similar triangles have sides that are proportional to each other. So let's use that. The hypotenuse of the smaller triangle, MSN, is MN, which we calculated to be 5. The hypotenuse of the larger triangle, NRQ, is NQ, which is 12. So the ratio between these two similar triangles is 5 to 12. Now let's use this ratio to relate the sides. In triangle NRQ, the side sitting opposite angle beta is RQ. And since RQ is just a side of our square, that means RQ equals X. In the smaller triangle, MSN, the side opposite angle beta is SN. Because the triangles are similar with ratio 5 to 12, SN must equal 5/12 of X. Now, from the previous equation, we know the entire bottom side, SR, is also equal to X, since it's a side of the square. And SN is just part of that side, so the remaining piece, NR, equals X minus 5/12 of X, which simplifies to 7/12 of X. We're almost there. Now let's go back to triangle NRQ one more time and apply the Pythagorean theorem again. This triangle has a right angle at R, with legs NR and RQ, and hypotenuse NQ, which equals 12. So we write NR squared plus RQ squared equals NQ squared. Substituting what we found, that's the quantity 7/12 of X, whole squared, plus X squared equals 12 squared. Let's expand that first term carefully. 7/12 squared is 49 over 144. So we get 49 over 144, X squared plus X squared equals 144. Now notice, X squared by itself is the same as 144 over 144 X squared. So combining our two terms on the left gives us 49 over 144 plus 144 over 144, which is 193 over 144. All multiplied by X squared, and that equals 144. To solve for X squared, we multiply both sides by 144 and divide by 193. On the right side, 144 multiplied by 144 gives us 20,736. So x squared equals 20,736 divided by 193. Finally, we take the square root of both sides to solve for x. The square root of 20,736 is 144, since 144 times 144 gives us that exact number. So our final answer is x equals 144 divided by the square root of 193, and that's the side length of our square.